This is lesson 5.4, writing linear equations in standard form. You should be on page 311. I want to do a quick review of what we've covered up to this point in this chapter. You've learned in lessons 5.1 and 5.2 how to write an equation in slope-intercept form. We spent the first two lessons on y equals mx plus b. The last few days we've learned how to write equations in point-slope form, which you see here. Today we're going to learn how to write an equation in standard form. Remember, standard form looks like this: ax plus by equals c. All linear equations, in other words, linear means straight line graph, all straight line graphs can be written in standard form, but that's really true for these also. So I can write a linear equation in slope-intercept form, I could write it in point-slope form, or I could write it in standard form. These three forms are kind of like brother-sister related to each other. They're not exactly the same, but they all are related because every one of those forms would create a linear graph. We're going to start off with something that they're going to ask you to do in the homework. They want us to be able to write equivalent equations in standard form. Okay, now remember, the word equivalent means if the ordered pair is a solution to the equation given, that same ordered pair would be a solution to the equivalent equations. I'll show you that in a minute. Here's how you write equivalent equations. It's super easy. You just multiply each side of the equation by the same amount. Now, the book showed two examples of that. It said write two equations that are equivalent. So here's what the book did. They decided to take this equation that I'm circling, and they're going to multiply everything it says here in blue by 2. So look what they did. 2x turned into 4x, minus 6y turned into minus 12y, and 4 times 2 turned into 8. They just multiplied each side by 2. So here is an equivalent equation. And here's another equivalent equation. They decided to multiply everything by a half. So they multiplied 2 by half and made it 1x, negative 6y by half and made it minus 3y, and 4 by half is 2. These are both equivalent. Here's what equivalent means again. 2, 0 is a solution to this equation. So just let's make sure we know why. If I put a 2 in here and I put a 0 in here, do you notice 2 times 2 is 4, 6 times 0 is nothing. Do you see how that's a true statement? Well, these are equivalent because if I take that same ordered pair and I plug it in for x and y, I get true statements again. 4 times 2 is 8. 12 times 0 is nothing. Do you see how I get 8? Or here, if I put a 2 in for x and I put a 0 in for y, 2 minus 0 equals 2. The equations are equivalent because the solution for this will also be a solution for those two. In other words, equivalent means you just rewrote the equation even though it has the same solutions. Let's try writing two equations in standard form that are equivalent to the one you see here. So I tell you what I'll do. For the first equation, I'll just multiply everything by 2, just like the book did. So I would get 2x minus 2y equals 6. I tell you what, for my second equation, I'll just multiply everything by 3. So 3x minus 3y equals 9. That would be two equations that are equivalent. You can pick whatever you want to multiply by to make your equivalent equations. Obviously, I wouldn't pick super big numbers. That just makes things more complicated. We have to be able to write an equation in standard form. These are the steps that I would suggest you follow. This is what the book's showing. I'm trying to spell it out so you understand exactly what the book's trying to show you. Here's how you write an equation in standard form. You first start out by setting up an equation. Do you notice here, in point-slope form, first. That's what we just got done in our last lesson. So start off in point slope form. Once you have point slope form, distribute. Move all the variables to the left of the equal sign, and then move all the constants to the right, and you're done. Okay? Let's try that on this problem here, problem 2. Let's actually try that, and then I'll do this in blue ink so it shows up nice. Okay, I need to write an equation in point slope form. So this is, to write an equation in standard form, I got to start in point slope first. So let me write point slope down up here on the sheet. There's point slope. Now remember, I got to get the slope first, and I don't know it. So let's figure out the slope. I'll do it down here. I have -1 minus -3 for my y's, and I have 3 minus 2 for my x's, and if I'm doing my mental math right, that's 2 over 1, and that's 2. So my slope is 2. Where I see m, I'll put in a 2. And now let's pick whatever point's easiest. I guess I'll pick that. It's got a -1 in it. 1's normally easy to work with. So I'll put the 3 here, and the -1 goes here, so don't forget that turns into y plus a 1. Okay, so I just did step 1. I set up an equation in point slope form. Step 2, let's distribute. So y plus 1 on the left will equal 2x minus 6 on the right. Okay, I did that. Step 3, let's move all the variables to the left of the equal sign. Well, that means I don't want the 2x here. Let me rewrite this stuff over here so I have a clean area to write. Let's get rid of that 2x. I don't want it here. Let's take away 2x from each side. Now you notice there's no x's over here to subtract from, so I'll just put the 2x minus 2x in front. So nothing minus 2x is -2x. This is a positive y, so I have plus y. I have a plus 1, and that would equal, these cancel, I have a -6 on the other side. Okay, I did step 3. Step 4, move all the constants to the right of the equal sign. Now remember, the constants are the numbers with no variables. I have a number here with no variable on the left of the equal sign. Let's get rid of it. Let's take away the 1 and cancel. -2x plus y equals -7. There's my equation in standard form. Do you notice how this form is matching standard form? So A is a -2 right now, B is a 1, and C is a -7. My equation is now in standard form. This is the process, maybe I should highlight it. This is the process right here that you need to follow to write an equation in standard form, and I'm following how the book did it, so I'm being consistent. Horizontal and vertical lines are special cases. Recall that when you have a horizontal line, the equation form is y equals a. Like if you look in the book right now at this picture, you'll see a blue horizontal line. I'm sorry, it's down here. The blue horizontal line is here. Okay? That line is 4 units below the origin. The equation for this line is y equals -4. Just write that in there. Remember, that's a special case. We learned that back in Chapter 4. I'm going to put the lesson 4.2. A vertical line is a special case. It has the form x equals b. If you notice the red line here, and maybe I'll just kind of mark it a little bit in red. It's this one here. This line is 4 units to the right of the origin. Its equation is x equals 4. These two are special cases. You cannot write the equation of a vertical line in slope-intercept form or point-slope form because a vertical line has no slope. Remember, a completely vertical line has an undefined slope. Let me erase that out of there. M is undefined for my vertical line, so I can't calculate it. So I can't write an equation in point-slope or slope-intercept form. However, you could write an equation for a vertical line in standard form. So let me write out what I had again. I had x equals 4, and you might be thinking, well, wait a minute, how is x equals 4 standard form? Well, it is, because here's what you really did. You have 1x plus no y's equals 4. Can you see how that's standard form? I didn't write the y because I have none. Okay, so a vertical line, when you put x equals 4, you actually wrote an equation in a simplified version of standard form. Let's practice writing an equation of a line. And let's go to the next page, because you're going to do this in your homework. They ask you to write equations of the horizontal and vertical lines that pass through the given point. Now, you typically wouldn't do this on graph paper, but this first problem I want to draw up on graph paper so you can see it. So you'll notice on graph paper I graphed -8, -9, just so you can see what I'm thinking. Okay? The horizontal line through that point would be here. And the vertical line through this point would be here. Let me do it in a different color just so it kind of stands out a little bit. That would be here. And they want me to write equations for those two lines. That one's a little bit sloppy, but it's good for now. Okay, so this line should be pretty basic. This line is 9 units down. This is the line y equals -9. And this vertical line, the vertical line is 8 units left. This would be x equals -8. Now, you shouldn't have to draw this picture to do this, okay? Look at the point. X is -9, I misspoke. X is -8, I meant to say. X is -8, y is -9. Do you see how that gives me the same equations? X is -8. Remember, is means equals. Y is -9. So when I go back for the next problem, when I see these 2 points, if I want the horizontal and vertical lines passing through, x has to equal 13 and y has to equal -5. So I can kind of picture in my head 13 right, 5 down. My vertical line is 13 to the right, so x is 13, and my horizontal line is 5 down. There's my equations. Keep moving here. Another thing we have to do is complete an equation in standard form. You will see questions like this in your book. Find the missing coefficient in the equation of the line that passes through the given point. There's one direction, and then there's a second direction. Let me highlight the second direction. Write the completed equation. Okay, well, this is really not very hard to do. They give me a point. This is x and this is y. Where you see x, put a -1 in there because x is -1. So -4 times the -1 plus b times the 1 equals 7. So -4 times -1 is 4. 4 plus b times 1 is b equals 7. I have to solve this. Take away the 4, b equals 3. I just found the missing coefficient. I'll highlight it in purple. I just answered the purple part of the question. The missing coefficient's 3. Let's go to the orange part. Write the completed equation. Well, my complete equation then would be -4x plus 3y equals 7. There's my completed equation. Why don't you go ahead and try number 6 on your own. Pause the video. And now I'm restarting the video. When you work this out, you should have gotten a is -4, and there's my equation. When I put -4 in for a, there's an equation in standard form. Last part of the video, you'll have story problems that they will ask you to set up an equation, and sometimes it's easier to set up an equation in standard form. So you notice in this problem, your class is taking a trip to the library. You can travel in small and large vans. A small van holds 8 people. A large van holds 12 people. Let's write an equation then. I can fit 8 people in a small van that's what the S is for, plus 12 in a large, and if I add those up, it would be the total people traveling. Now, do you notice, they tell me my class can fill 15 small vans and 2 large vans. So if I put a 15 in for S and a 2 in for large van, that's 144 people. Okay, so there must have been 144 people in the class. They want me to graph the situation. I'm going to get my layer on here. They want me to graph the situation. So if there's 144 people in the class and 8 people fit in a small van and 12 in a large, they want me to graph that equation. Now, that's standard form. I would highly suggest you find the x-intercept and y-intercept. Do you remember, to find the x-intercept, plug 0 in for y, which is why the 12y disappeared. 8x would be 144 divided by 8. X is 18, which means you have to graph the point 18, 0. By the way, I switched in my problem. The S's are the X's and the L's are the Y's, so I just put X and Y. And then to find the y-intercept, plug in a 0 for x, which makes x disappear, and 12y equals 144 divided by 12. Okay, so now, don't forget, x stands for small van, and y stands for large van. So let's start graphing now. So let's go over to the graph paper, and you can see they plotted 18, 0. Be aware of their scale. I'm going to highlight their scale. They chose scales of 2. And then you can see they also plotted the point 0, 12. Let's label our graph. This is number of small vans. I'll put S vans. And over here is number of large vans. Now, if I plot these 2 points, I can now take my ruler and draw a line, which you see that I did, but don't extend the line because I can't have negative small vans, I can't have negative large vans. Now, here's why you would graph this problem. This problem has multiple answers. Here's what this graph is telling me. I could take 0 small vans and 12 large vans and fit the whole class on the class trip. Here's another option. I could take 18 small vans and 0 large vans. Do you notice? Let me get my highlighter out. I see a couple more options. Here's one right here. I could take, for the class, 2, 4, 6 small and 2, 4, 6, 8 large. I could do 6 small, 8 large vans for the class trip, or 2, 4, 6, 8, 10, 12. I could take 12 small and 4 large vans. So this problem actually has 4 different correct answers to it. I'm going to pause my video here. If you have questions, make sure you ask in class.